Hello. In today's lecture, we will do more problems on trigonometry and vectors. So let's just remember, if we have a triangle right at A, the sine of one of the angles, it's the opposite side divided by the hypotenuse, okay? Where the hypotenuse is the side facing the right angle. What I want you here to remember, so if I have an angle theta, sine theta is opposite over hypotenuse. Cosine theta is adjacent over hypotenuse, and tan theta is opposite over adjacent. And this is the hypotenuse. This is the hypotenuse. It is the side facing the right angle. Okay. Pythagoras theorem, the hypotenuse square is equal to one side square plus the second side square. Let's see how we apply this. Okay, vectors, if I have a vector f, each vector has two components. Each vector has two components, fx and fy. Fx is the magnitude of vector f multiplied by cosine of the angle theta, which is the angle the vector f makes with the x-axis. Okay, the angle the vector f makes with the positive x-axis. Fx is f cosine theta, fy is f sine theta. You can just memorize these. You just have to pay attention to that fx and fy can be negative or positive. Depending if I'm going right, fx will be positive. If I'm going left, fx will be negative. Fy, if I'm going upward, it will be positive. If I'm going downward, it will be negative. Okay. How to draw fx and fy? This is my vector f. I start moving along the x-axis. Until I make 90 degrees with vector f. Okay. Then, until I reach the tip of vector f. Then I start moving with a 90 degrees until I reach the tip of vector f. This is fy. So fx, fy, they make, there is here a right angle where the hypotenuse is vector f. Fx and fy are the two sides. Put a Pythagoras theorem, since this is here a 90 degree, f squared. So if he asks me about magnitude and direction of a vector f squared is fx squared plus fy squared. This is the magnitude. So f will be square root of fx squared plus fy squared. If he asks for the direction, that is angle theta, I say tan theta is fy over fx, implies theta equal tan inverse of fy over fx. So if the question is asking about magnitude and direction, you just say f is equal square root of fx squared plus fy squared. Theta is equal to tan inverse of fy over fx. Tan inverse means shift tan on the calculator. Let's do some exercises. Let's start with trigonometry. So a person standing 4 meters from the base of a mountain. So he is standing over here. Measures the angle of elevation from the ground to the top of the mountain to be 25 degrees. So this angle is 25 degrees. So this is in this triangle. This triangle. He measured that the angle is 25 degrees. The same person then walks another 5 meters. So he walks another 5 meters. Okay, until he reaches here. And he measures that the angle is 20. So this is another right triangle. How tall is the mountain? So he wants us to calculate this h. Okay, so let's start with the first triangle. Okay, this is a triangle. I have the angle, I have the opposite, and I have information about the adjacent. So which one I use, sine, cosine, or tangent? If I go to there, I will find that the sine and the cosine need information about the hypotenuse, but I don't have any information about the hypotenuse, so I must use the tangent. So tangent of a 25 in this blue triangle, it's equal to opposite over hypotenuse. So tangent of 25 is equal to h divided by how much is this distance? it is 4 plus x. So it is h divided by 4 plus x. I cross multiply, I get h equals 0.4, which is tangent 45, divided times 4 plus x. So this is h from the first triangle. Now, I use the information from the second triangle. I use the information from the second triangle. So now we are here. And this is the triangle. Okay. So also I have the opposite, which is h. I have the angle, which is 20. And I have information about the adjacent. So also I use tan. In this case, it will be h divided by 9 plus x. Tangent 30 is 0.3. So h will be 0.3 here, cross multiply. So h will be 0.3 into 9 plus x. So h equals this and h equals this, but h is equal to h. So the first amount is equal to the second amount. 0.4 into 4 plus x equals 0.3 into 9 plus x. Expand 1.6 plus 0.4x equals 2.7 plus 0.3x. Bring 0.3x this way, 0.1x will be, bring 1.6 the other way, 1.1, so x is equal to 11. Then he's not actually asking me about x, he's asking about h. I use any of these two equations, any of them. I have x now, it's 11. So I just plug 11 here and I will get h is 6 meters. You can use the other equation and you must find the same answer. Let's do another question. This is page 13, example 2. So I have a blimp 4 kilometers above the ground. You don't care what this a blimp is. Don't worry what it means. Look just at the drawing. So it's 4 kilometers above the ground. Measures an angle 24 degrees from its horizontal line. Assuming the ground is flat, how far away along the ground is the house from the blimp? In other words, he's asking about x. So we have to calculate x. Again, if I look at this triangle, okay, I have the opposite side. I have the adjacent side, and I have information about the angle. How much is this angle? Do you all agree that this angle is equal to 24? Why is this 24? Because these are two parallel lines. So parallel lines, and there is a Z. So whenever I see this Z, implies alternating angle. This is from grade 9, I think, or grade 8. So these are two parallel lines and there is a Z between them. These are called alternating angles and they are equal. So now back to my triangle. I have the angle, I have the opposite, and I have the adjacent. So which equation I use? I again use the one for tangent theta, which is opposite over adjacent. Tangent 24 is opposite 4 over x. X equal 4 over tangent theta. Use the calculator, you'll find x. Let's do one more. So the drawing shows a person looking at a building on top of which an antenna is mounted. So this guy over here, he's looking at a building where there is an antenna on top. The horizontal distance between the person's eyes and the building is 85 meters. So this is how far he is from the building. So this is 85 meters. In part A, the person is looking at the base of the mountain. Look, where is he looking? He's looking here at the base. Okay. In part A, the person is looking at the base of the antenna and his line of sight makes an angle 35 degrees with the horizontal. So when he looks at the base, the angle is 35. In part B, the person is looking at the top. In part B, he's looking at the top of the antenna. So this time, he's looking at the top. Okay. And his line of sight, and in order to reach this site, his angle is 38. The angle he makes is 38. Notice here that this distance is the same. Now, how tall is the antenna? So he's asking about H, find H. Okay, find H. So here I'm assuming that this distance from here to here to be L. So in this right triangle and in this, okay, so I'm assuming in this right triangle, this side here is L. Okay, now again, I have information about the adjacent, I have information about the angle, I have information about the opposite. So what do I use? I use tangent again. So tangent 35 is L over 85. I will get L to be 59.5. Now the question is not to find L, it's to find H. So I'm done with part A. Now I come to part B. How long is this side? How long is this side? This side is L plus H, right? So I have the opposite side, it's L plus H. So again, tangent, this time the angle 38 is equal to L plus H divided by 85. This is a right triangle, right at this angle over here, okay? So the opposite of 38 is L plus H and the adjacent is 85. Instead of L, I put 59.5. 59.5 plus H equal 85 times 10, 38. On the calculator, 85 times 10, 38 is 66.4. So I get H equal 6.9 meters. Okay, let's do one more exercise on vectors. So here I just want you to remember that every vector has two components. And in order to get the addition of two vectors, I have to add the components. Okay, so in this exercise, he's giving me two vectors. A bird flies 100 meters due east from a tree. So this is the first vector A. Okay, this is the first vector A. Then 200 meters northwest, that is making angle 45. So then he's going this way. Okay, what is the bird's net displacement? He's actually drawing for me graphically. Remember yesterday we said we can get this graphically or algebraically. Graphically, he's drawing it for me. So I went this way, then I got this way. So graphically, this is vector C. This is vector C graphically. But he's asking about the displacement. So he's asking me about the magnitude, actually, the magnitude and the direction. So in order to get the magnitude and the direction, I have to remember that the magnitude of a vector is square root of fx squared plus fy squared. And the direction is tan inverse of fy over fx. So I have to come here and I have to calculate. I have calculate Cx and Cy. How to calculate them? Cx is equal to Ax plus Bx, and Cy is equal Ay plus By. We took this yesterday. So I have to calculate Ax, Ay, Bx, By. So let's focus on vector A. We said that Ax is how far I go on the x-axis to reach vector A. Here, you should remember from yesterday, if a vector is along the x-axis, Ax will be all of vector A. And there is no Ay because I'm not going up and down. So Ax is A, Ay is 0. Okay, Ax is A. It can be plus or minus, but since it's going with the positive x-axis, so it's a plus 100. Now vector B. Let me erase vector A from here. Let's focus a bit on vector B and see how do we go to vector B. First, I go along, let's change the color. First, I go along the x-axis until I reach the tip. Then I go along the y-axis. First, I go along the x-axis until I reach the tip. Then I go along the y-axis until I also reach the tip. So this is bx, this is by. You must memorize, just memorize it. Bx is equal to b cosine theta, okay? Where this is b and it's the adjacent of this angle theta. So it is b cosine theta, okay? And by is b sine theta. Just pay attention that bx is going in the negative direction. So it is minus because it's going in the negative direction. So it is minus. So bx is minus b, which is 200, times cosine 45. And this will be minus 141.4. by is b sine theta and it's going upward. So it's plus. So it is plus 141.4. Now I have ax, ay, bx, by. So what is cx? It's ax plus bx. I just add 100 minus 141.4. I get minus 41.4. cy is ay plus by. So it is 0 plus 141.4. So it's 141.4. This is vector c. So the magnitude of vector c is square root of 41.4 square plus 141.4 square. C will be this much. Just use the calculator. The direction theta is tan inverse of the y component over the x component. So 141.4 divided by 41.4. So theta equal 73.6. Okay, so that's the lecture of today. Thank you so much. And tomorrow we will start with chapter 3, that is motion in 2 dimensions. Talk to you tomorrow.